Hi, and welcome to this short concept bite which introduces the second law of thermodynamics and introduces the concept of entropy. Entropy is often poorly understood, but the second law of thermodynamics is one of the most important laws, not just in thermodynamics, but in our understanding of the universe. The first thing we have to understand is the concept of spontaneity. A spontaneous process has a tendency to occur without work needing to be done in order to bring about the change. We know from experience that if we forget about a cup of tea, it goes cold. The spontaneous flow of energy in the form of heat is from the hot tea to the cooler surroundings. We know that tea doesn't spontaneously get hot, although we can raise the temperature by rapid mixing, doing work, just like Joule. We also know that our fridges and freezers don't cool down below ambient temperature without them being plugged in. In fact, one possible statement of the second law is that heat does not pass from a body at low temperature to one at high temperature without an accompanying change elsewhere. Just like the first law, there are multiple statements of the second law of thermodynamics, and again these often differ because of the types of thermodynamic system. The simplest of these statements refers to our simplest type of system, the isolated system. The entropy of an isolated system tends to increase. We have not defined what entropy is, but whatever it is, it increases. Another statement says that the entropy of a universe increases during a spontaneous change, just to remind you that the universe is the system and surroundings together. So far, I haven't said what entropy is, and although I will define it from a microscopic perspective in another video, the classical definition related to the energy transferred as heat reversibly to or from the system. This relationship says that the entropy change is bigger for a given quantity of heat at low temperatures. William Thomson, later Lord Kelvin, made the observation that no cyclic process is possible in which heat is taken from a hot source and completely converted to work. With our understanding of the second law, this makes sense, because if the temperature of the hot source falls as heat is transferred, then the entropy of the system will also fall. And because the entropy of the universe can't decrease, we can't convert all of our internal energy into work. Rudolf Clausius was thinking about the flow of heat between two bodies, and he said heat doesn't pass from a body at low temperature to one at high temperature without an accompanying change elsewhere. Again, with our understanding of entropy, this makes sense, because if heat is transferred from a cold source to a hot source, then the decrease in entropy of the cold source is bigger than the increase in entropy of the hot source, which again breaks the second law of thermodynamics. Entropy, like internal energy and enthalpy, is a state function, and so it doesn't matter how we go between two states, it just matters what those two states are. We can work out the entropy change for that process in just the same way as we would using the products minus reactants approach that we see in Hess's law. I hope that this concept bite about the second law of thermodynamics has been useful and made you think a little about some of the thermodynamic processes that happen all around you all of the time. As always, if you have any questions, please do not hesitate to ask.